Okay, today guys, we are going to talk about another type of conic section called hyperbolas. And these resemble parabolas, but there's two of them, and they're restricted by these asymptotes. I've done the asymptotes in kind of an orange color. Up until now, all the asymptotes that we've dealt with have been vertical or horizontal, and these are now slanted. And we're going to talk more about those in a little bit. The main thing I would like for you to get right now is that hyperbolas can face either horizontally left and right or vertically up and down. So you can look like this or look like this. With this conic section, your focus points, you'll have foci again. You'll have two of them here and here. Or if it is a vertical one, you'll have them here and here. So those will be where your focus points are. And again, we'll be calculating those today. If you look at the general forms of the equations, you'll notice a difference. When the hyperbolas face left and right, the x comes first and the y comes second. When they're facing up and down, the y comes first and the x comes second. In both cases, they have a minus between them. In fact, that's how you tell that you're looking at the equation of a hyperbola. And similar to ellipses, they're equal to 1. Now, you might have to do a little work to get them to 1, but they should equal 1 in this form that we work with. Now, I always put A under X and B under Y because that just makes sense to keep it the same all the time. If you are in textbooks studying ellipses or hyperbolas, they may switch those depending on which one's kind of dominant in the shape orientation. But I just keep it simple, and I keep A's under X and B's under Y so that there is no confusion in your counting left, right, up, or down. I would recommend sticking with my way unless you just want to venture out and read another textbook. Okay, one last thing that I need to mention is that although it's not part of the actual line of the graph, this point where the asymptotes cross is the center. That's where it's balanced on each side of that, and we have one over here, the center over here. So the center here, the center there, we will be finding those as well. Okay, now we're going to go over some of the things that you can calculate given the equation. And again, we're going to be calculating a c. So c squared in this case is the big plus the small. So with ellipses, you are subtracting. With hyperbolas, you are now adding. Your big and your small are your a squared and your b squared. So if you just wanted to think of it as c squared equals a squared plus b squared, then that might be an easier way to remember it because you think of the Pythagorean theorem that way. So whatever works for you, just remember to add when you're in hyperbolas and subtract when you're figuring it out in ellipses. Again, C is the distance from the center to your focus points. So those will come in handy when we're trying to graph the focus points. Another thing that we'll be able to calculate is the slope of our asymptotes. The slope of those slanted lines, you can use the A and the B, and one will be positive because it'll be going uphill, and the other will be negative because it's going downhill. So the two slopes of those asymptotes would be B over A and negative B over A. Okay, on occasion, you'll be needing to find the equation of those asymptotes. And so we're going to use point slope form that you might have learned in Math 1 or Math 2 to calculate those. We'll be using this a lot next year. But we're going to use the slope that you find here and the center that you calculate from the original equation, and you're going to plug them into point slope form, which is y minus something equals something, x minus another something. Well, what goes where? The center is a point, so I'm going to call it x1, y1 for the moment. The x and y from the center, you'll have actual numbers there, but you plug the x value in with the blank at the x. So this would be where you plug that one in. You plug the y value in with the blank at the y. And the slope, which we normally use the letter M for slope, the slope goes in front. And so that's where you plug it in, and you'll be able to get an equation. If you want to put it in slope-intercept form, which is y equals mx plus b, you can work on it from there and put it in that form. So that's everything you need to know before we get started. Okay, our first example today is going to be similar to what we did with the ellipses to begin with. It's not in the correct form, but it's a really easy fix. You know it's supposed to equal 1, so divide by 16. And then reduce. So 4 and 16 is going to reduce and give you x squared over 4. The y squared didn't have anything to cancel, so it still gets the 16. And then the 16 over 16 becomes 1. Now it's in the form of a hyperbola that we can graph. It doesn't have the parentheses on top, which means that our center is at 0, 0. And then I go looking for my numbers as I did yesterday. So a, again, I like to keep that under x squared. So the 4, we take the square root of that and get our a to be 2. We take the square root of the 16 and get our b to be 4. And then c squared would be the numbers added together that are on the denominator. So 4 plus 16, which is 20. If we take the square root of that, that's your c. So it's the square root of 20. That might be written as 2 square roots of 5, or it might be written as a decimal 4.47. Certainly, if we're going to graph it, this 4.47 is the way we want it because that's where we can best estimate where to put our points. The slope, as I mentioned, is positive and negative b over a. Well, b over a, 4 over 2, is 2. So our slopes, I'm going to erase that for a second. Our slopes are positive 2 and negative 2. Okay, now we're going to try to graph it, and you'll have to bear with me on the straight line situation. Our center is at 0, 0, so that's right here. The 2 and the 4, you're going to do the same thing that you did with an ellipse. The A is going to be left and right, so I'm going to count 2 to the right, put a dot, 2 to the left, put a dot. And the 4, I'm going to, from the center, I'm going to go up 4 and down 4. And then I want you to make a box that goes through those. That box is not going to actually be your hyperbola, but it's going to help shape everything that you do. So we make this box through those points. Then your asymptotes are going to go through those corners, and I'm going to let the computer help me draw that one, to go through the corner, through the center, and then out the other corner. So something like this, to the best of your ability. This one's a little hard because I don't think I got my box just straight over here. And then I'm going to do the other one facing, going in the positive slopes direction. And again, when you draw these on your own paper or on graph paper, you're probably going to be better at this because you want to make sure it goes through the corners of your box and the center. And so yours will most likely line up a little bit better than mine. Now, to draw the to draw the hyperbola, you're going to decide whether it's a left and right or an up and down. So when you look at the equation, we had an x squared minus a y squared. That means it's left and right. The vertex for this is going to sit on the edge of the box. So since the x squared is first and we're doing left and right, I'm going to do one at -2, a vertex at -2, and then I get close to my asymptotes and let them dictate the width of that hyperbola on this side. Then I'll do my right side. Its vertex will be at 2, and again that's going to shape my graph by trying to get close to my asymptotes, grow close to my asymptotes. That's the actual graph. That's the points that work in this equation. And the other thing that we want to do is, because we found C, we want to locate those foci. So our C was 4.47. That means from the center, 4.47. So if I count right, 1, 2, 3, 4, and a little bit less than half to the best of my ability, there is one focus point. And left, 1, 2, 3, 4, and a little bit less than half, there is my other focus point. So these two would be considered the vertices at -2 and +2. The foci would be, and they have disappeared now, at 4.47 and -4.47 on the x-axis. Okay, for my next example, I'm going to do one that's not in the form that we need it in, and we have to complete this square. As you will notice, that happens a lot in this unit. So, the first thing I'm going to do is get my x's together, so 4x squared plus 8x, and my y's together. That should be a minus 3y squared. And I'm going to subtract the 16 to the other side, as usual. And here, I've got these x's to deal with, but I have that 4 in front that I need to factor out. So if I factor that out, I get x squared plus 2x, and as usual, I leave some space. Now, we didn't have a plain y over here. It's just 3y squared. That means that this piece is going to be similar to that first example where we just had to divide. So I'm going to let that tag along for a minute. Now, I'm going to complete the square. So half of 2 is 1, and 1 squared is 1. But because I had to factor out a 4, I'm actually adding 4 on this side. So 1 times 4 is 4. I'm going to add that to the other side. Okay, then I go to factor, and this always is going to factor to whatever this first sign is and half of this number. So x plus 1 squared. And on this side, I'm going to go ahead and combine the -16 and the 4 and get -12. And again, like the first problem, I have something other than 1 here, so I am going to divide by that number so that I can get a 1 on this side. But I have to divide by that number everywhere. Now, when I divide here, 4 and 12, that's going to reduce to 1 and 3, but I have a negative, so I'm going to stick it out front. So I have negative x plus 1 squared over 3. Here, I have 2 negatives, so that'll make a positive. And the 3 and the 12 are going to reduce to 4. And then on this side, 12 over 12 is 1, so -12 over -12 is 1. And if you notice, now I have this equation, but it doesn't have a minus in the middle of it, and it's a hyperbola. This does have a negative in front of it, the first piece, so I'm going to switch these two. And my equation is now going to be y squared over 4 minus x plus 1 squared over 3. And we're going to set that equal to 1. So this is the form that I want to work with. Okay, now we have it in a form that we can work with. We're going to list out everything that we know. So, looking at the center, my y squared is by itself, so my y is going to be 0. But the x has a plus 1, so I'm going to get a -1 for my x. And then this is where I look at the a's and b's differently than textbooks. I look under the x for a. And this is the first time we've run across a number in our notes that was kind of ugly. Normally it's something we can take the square root of easily. Well, we don't know the square root of 3, so I'm just going to write the square root of 3. Because I might need to graph, I'm going to go ahead and change that to 1.7 so that I can have that information as well. The b, I'm going to take the square root of 4, which is 2. And then my c squared is the big plus the small, or the a squared plus the b squared. So we're doing 4 plus 3, which is 7. And your c will be the square root of that, which is about 2.6. Okay, we'll need that to graph. Then, if you want to look at the slope, it is your positive and negative b over a. Well, b over a is 2 over the square root of 3. So if we rationalize that, and we've done that one a lot with the unit circle, we should get 2 square roots of 3 over 3. And we know that there's a positive and a negative slope because we have 2 asymptotes, one with a positive slope and one with a negative slope. So that is my calculations getting ready to graph. Now we're ready to graph, so I'm going to start with my center as usual. It is at -1, 0, so that is right here. And so we're a little bit to the left this time. I'm still going to count things the same way. My A is 1.7, so I'm going to go left and right of that point, 1.7. That again, I'm just trying to estimate it when I'm sketching these things by hand. Left and right, 1.7, and I hope it stays on there. And then my B is 2, so I'm going to go up and down from the center 2. And I'm going to make my box to the best of my ability. You may want to use a ruler to make things more precise. And after I have my box drawn in, then I want to do my asymptotes, which are going to go through the corners and the center. So I have one here, and that one should be this negative sloped one. And I'll have one here, and that one is my positive sloped one. So once I get those in, I'm going to decide, does this face left and right or up and down? Well, since the Y comes first after we have it all fixed, it's an up and down. And so I want to put my vertex on the dot that we made that was 2 above the center. That's the vertex. And I'm going to draw getting close to those asymptotes without crossing them, letting them dictate the shape here. And the other one facing down will have the vertex at the -2, the -1, -2. And again, we will get closer to the slanted asymptotes as we draw those. What's left is the foci, the focus points, and since those we got a C of 2.6, you should go from the center about 2.6 to the best of your ability, so it should be fairly close to this. And there's your focus point. And down 2.6. And there's your other focus point. So that's our example 2. Okay, we're going to do one last example. And this one is already in the form that we need to work with, so we don't have to complete the square. We just need to identify everything. And the center, be careful, especially with these when the Y comes first, that you put the Y number in the Y spot of the point. So we'll have a +1 for the Y and a +2 for the X. Again, A, I look at under X, the square root of 4 is 2. B, under the Y, the square root of 9 is 3. And then C squared would be 9 plus 4, which is 13. We take the square root of that, and you can either write it as the square root of 13 or about 3.6. And then the slope of our lines, B over A, so that will be 3 over 2 or -3 over 2. Now we're ready to graph. Okay, so I'm going to start with my center at 2, 1. So over 2, up 1. There's my center. And with my A being 2, I'm going to count right 2 and left 2. With my B being 3, I'm going to count up 3 and down 3. And then I'm going to make my box. And again, I highly recommend a ruler if you want to be as precise as possible. And that's just to help you get this shape right. Now I'm going to put in my asymptotes. Make sure that when you do your asymptotes that you are going through the center as well as the corners of the box. And then you're ready to draw your hyperbola. Since this is a y squared first equation, you'll be up and down. Put your vertex on that edge of the box where you went to draw it, and get close to your asymptotes, but don't actually cross them. I made a mistake right there. Same thing down here. Put your vertex, draw close to your asymptotes, let them shape your graph, and you have the up and down hyperbola. The last thing to do is put in your foci, which are 3.6 from your center. So up 3.6, so very close to the vertex, is a focus point, and down 3.6 is another focus point. So there is this graph. One last thing that I want to show you with this is how to get those equations of tangent lines. So I'm going to use the center and the slope that we just used in problem number 3 and get the equations of the two tangent lines. So we have two of them. One has a slope of positive 3/2 and it goes through the center to 1. The other has a slope of negative 3/2 and it also goes through the center to 1. So you want to start by setting up your point slope form like I mentioned in that first slide. Then you want to plug in the values. The y value of your point goes with y, the x value goes with x, and the slope goes in front. When you have those plugged in, that's actually the form of a line that is a usable form, but since most people like to do slope-intercept form, you can distribute your slope, so 3/2 x minus 3/2 times 2 will be just 3, and then add 1. So your y will be 3/2 x minus 2. That's the equation of the one that's going uphill. And then over here we can do the one that's going downhill. So y minus equals x minus. I'm going to again plug the y value in with y, the x value in with x, and the slope in front. And I'm going to distribute the negative 3/2, so I get negative 3/2 x. And then when I distribute here, negative 3/2 times negative 2, I have to consider the signs. So that'll be a positive 3. And again, I'm going to add 1 to both sides. So I'm going to get y equals negative 3/2 x plus 4. So these are the two equations, the one that's going uphill, the one that's going downhill, of the asymptotes if you need them. It's that simple. Once you've come up with the center and the slope, you should just be able to plug in and get those answers. See me for your assignment.